Okay, now that we talked about degrees, we'll jump to radians. Radians are what I prefer to work with, and it's actually what we use most in higher math. We will see degrees again when we do vectors. You will see degrees in some science applications. So again, being able to work in both is very helpful. Really, first quadrant is where your main focus should be, but we will work with the whole unit circle in here. I like to, when I'm teaching the unit circle from very scratch, go around the unit circle in 12ths. So the reason the unit circle is so nice in radians is that all the way around the unit circle is 2 pi. And just like all the way around the unit circle in degrees is 360, all the way around the unit circle in radians is 2 pi units. Now the reason that is the case is actually mathematical. So all the way around the unit circle is the circumference. That's the circumference of the circle. And the equation for circumference is 2 pi times radius. Well, the radius of our unit circle is easy to forget because we usually look at it as this humongous thing so we can fit all our values in. But the radius of the unit circle is just 1 unit. So the equation of the circumference is 2 pi times 1. So the circumference of this circle is just 2 pi. So that's all the way around. I like to, when I'm teaching this from scratch, count around the unit circle in 12ths. If you just want to straight up memorize everything, that's absolutely fine. I think it's really helpful to be able to kind of count around and understand where all the values come from. So I'm going to put a couple benchmarks on here for us, and then we'll see where all these numbers came from. So all the way around is 2 pi. That means half of the unit circle over here equal to 180. Half of the unit circle is pi unit, 1 pi unit, or just pi units. And then half is going to be pi over 2, so that's up at 90. So those benchmarks are kind of nice. I'm going to go ahead and go from 0 to pi and count over in 12ths. And I think if you've never seen the unit circle before, hopefully this will help you understand where these crazy angle values come from. So not all of these values when we count around in 12ths. You can see this is not really broken up evenly, and we don't have 12 slices. We're going to have to make some. So here. So here, in between, is going to be pi over 12. That's not a value that's on our circle. It's there. It's right in between those first two angles, or 0 and 30. We don't memorize that value. We don't memorize that ordered pair. That means that this angle value right here is 2 pi 12. And this one is 3 pi over 12. And this one is 4 pi over 12. In between here would be 5 pi over 12. Up at the top at pi over 2 is 6 pi over 12. I'm going to keep going here. We'll get the top half done. In between 90 and 120 is 7 pi over 12. Equal to 120 is 8 pi over 12. At 135, 9 pi over 12. 10 pi over 12. 11 pi over 12 is here in the middle. And this guy here is 12 pi over 12 is equal to 1 pi. So if we go back around and reduce our fractions, we're going to get the values that we typically memorize on our unit circle. So pi over 12 here does not reduce. 2 pi over 12 too does. 2 pi over 12 is equal to pi over 6. 3 pi over 12, 3 goes into 12 4 times. That's equal to pi over 4. 4 pi over 12, 4 goes into 12 3 times. This is equal to pi over 3. 5 pi over 12 does not reduce. And 6 pi over 12 is equal to pi over 2. So there's the first quadrant of the unit circle in radians. Over here on the other side, 7 pi over 12 does not reduce. 8 pi over 12, 4 goes into 8 twice. 4 goes into 12 3 times. 2 pi over 3. 9 pi over 12, 3 goes into 9 3 times. 3 goes into 12 4 times. That's 3 pi over 4. 10 pi over 12 is the same as 5 pi over 6. 11 pi over 12 does not reduce. And 12 pi over 12 is equal to 1 pi, or just pi. So when introducing the unit circle, it's a lot of numbers, and it's a lot of numbers that are in fraction form with pies in them. And so because of that, I think it was very, very confusing. But if you understand that this top half of the unit circle here is just one whole, kind of break it into 1, and then half, and then you can think of this as 1/6, 1/4, 1/3, 1/2, 2/3, 3/4, 5, 6, and 1. It would be nice if they all had a common denominator. That's why I like to do this in 12s to start with, because it does kind of break down nicely into 12s. All of those can be made into 12s. All right, we're going to keep going into the bottom half of the unit circle in the same way, in 12s. And then I'll show you some of the relationships that are going on here. Okay, so that was 12 pi over 12 was the same as pi. So here in the middle is 13 pi over 12, 14 pi over 12, 15 pi over 12. The next angle is 16 pi over 12. In between here, 17 pi over 12. So all these in between guys that we don't memorize don't reduce. 18 pi over 12 is a 270 straight down. 19 pi over 12 is one that we won't memorize. At 300, 20 pi over 12. 21 pi over 12. 22 pi over 12 is equal to 330. 23 pi over 12 does not reduce. And 24 pi over 12 is equal to 2 pi. All right, so let's go back and reduce these so we have the unit circle completely filled out. 13 pi over 12 does not reduce. And actually, if you want to pause this video and go ahead and reduce those for yourself and just double check your work, that's probably a good thing to do at this point. Great, hopefully you have paused and have these filled out. 14 pi over 12 is 7 pi over 6. 15 pi over 12. Let's see, 3 goes into both, so 3 goes into 15 5 times, and then 12 3 times. Oh, 4 times. 4 goes into 16 4 times, and then to 12 3 times. That's 4 pi over 3. Straight down, I'm going to divide both those by 6, 3 pi over 2. Skip over 19 pi over 12. 20 pi over 12. 20 pi over 12, 4 goes into 25 times. 4 goes into 12 3 times. 21 pi over 12 is 7 pi over 4. 22 pi over 12 is 11 pi over 6. And that's the unit circle. So that's the unit circle in radians. I'm going to pause for a second and get rid of kind of our extra angle values here, do a little bit of erasing, and then I'm going to show you some relationships between these angles. Okay, relationships between angles. So now my unit circle is a little cleaned up. and we can talk about the relationship between these angles. So what we have here is all of our angles in radians, and if you look across the unit circle, some of these angles have the same denominator, and there's a pattern to the angles that share the same denominator. I'm going to get a highlighter into this for you. So if you look at, just start with pi over 6, and if you look kind of around the unit circle for where pi over 6 happens, we have our sixths happen. We have 5 pi over 6, we have 7 pi over 6, and we have 11 pi over 6. Here's the thing. All of those angles that have 6 as a denominator are the same distance from the x-axis. So they are all 30 degrees from the x-axis. That is not an accident, okay? This also means that these ordered pairs that you're going to see on the next video, if you would like to watch that video, the ordered pairs that are going to be there are going to be the same fractions. You're going to have different signs because they're going to be in a different position, but they are the same distance from the x-axis if you take away those signs, kind of if you look at the absolute value. Now let's look at the fourths. So our fourths are here in the middle. Here's a fourth. Here's a fourth, 3 pi over 4, and 5 pi over 4, and 7 pi over 4. And just like with the thirds, these are all the same distance, the same angle with the x-axis. All the fourths make the same angle with the x-axis. And those ordered pairs, when we get to doing the ordered pairs, are going to be the same fractions. So you probably already guessed, even if you haven't seen this before, that the same thing is going to be the case for the thirds. And you probably actually started looking ahead there at the thirds. All of the thirds are pi over 3 radians away from the x-axis. We call this kind of a bow tie situation because if we linked these up, it looks like a bow tie. Right, I'm going to get rid of those. And we will link those up when we're talking about the right triangles that we make to get those ordered pairs. Now the thing that kind of throws this off is that this doesn't really work for the, well, for the x-axis you have 0, right? I mean here these two are 0 away from the x-axis and they have the same denominator of 1, 2 pi or 0 and pi. The other thing we have here though is the halves are right with each other. So there aren't, those 4 kind of work. You have the pair of 2 and then the pair of 2. So that should help you kind of make those denominators if you're practicing the whole big picture of filling out the unit circle and where these live. The sixths are all kind of tight into the x-axis. The sixths, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 are all pi over 6 units or 30 degrees away from the x-axis. The fourths are all pi over 4 from the x-axis. The thirds are all pi over 3 from the x-axis. The last thing that I wanted to add in here is that a lot of students like Mr. Graham's little kind of mnemonic device for remembering the order of the fractions in the first quadrant. He takes it back to baseball and calls it a 6-4-3 double play. So 6-4-3 is a double play that's pretty common in baseball, but that's how he helps students remember this 6-4-3. Oh, I'm in highlighter mode and it does not like to write in highlighter. Sorry about that. So 6-4-3 is the order here, starting after 0, going around the circle. 6, 4, 3. And then really, if you start over here at pi, it works again this way. 6, 4, 3. That's how your denominators work. Starting at the x-axis every time, though. You can't restart. Don't restart it like pi over 2. They'll be in the wrong order. A couple other relationships that we usually talk about. In the first quadrant, all of your numerators are pi. In the second quadrant, all of your numerators are 1 less than the denominator. Bottom minus 1 times pi. I don't feel right now putting that pi in here. In the third quadrant, all of your denominators are 1 more than the numerator. So bottom plus 1 times pi. And in the fourth quadrant, all of our numerators are 1 less than double. And if you think about this final value being 2 pi, that kind of makes sense. So all of our tops over here are double minus 1 times pi. The radians are a lot, and they're patterns that you will get really used to. But the more you work with it, and you kind of got to trudge through it, the better you will get. If you are a visual person, then maybe looking at the unit circle is going to help you. If you really need to just write and write and write and write, then filling out a blank unit circle is something that is going to be helpful to you. I think it all depends on the kind of learner that you are. I've definitely put a lot of resources on our Canvas page, a lot more than I've had in the past. So hopefully some of those will be helpful for you, and hopefully this video is helpful for you. If you haven't seen the unit circle values before, or you could use those re-explained, that is going to be the next video down.